So welcome everybody to our next problem in cross products. So what we're asked to do in this problem is that we're given 3 points A, B, and C, and we're asked to find the distance from A to the line passing through B and C. And so when they say the distance from A to the line passing through B and C, that's the distance to the closest point on the line from there. Well, if we kind of draw this picture to see what we're talking about, then we've got our point B, and then we've got our point C there, and we've got our line that's passing through those 2 points. Then we've got our other point up here, that's point A. And so what we want to know then is what is going to be that shortest distance. Well, one thing that we can kind of imagine is that shortest distance is really going to be the point where that distance is going to be at a right angle to that line. And so one thing is that if we imagine the line, the vector, that's in the direction of B and C, and then if we want to imagine the point or the vector from B over to A, then for that vector, this distance that we're really talking about is really just kind of the orthogonal component. So it's the length of the orthogonal component of the vector BA and in the direction of the vectors BC. And so let's see if we can go ahead and figure out what that value is going to be. So if we call that distance D, then we know that we have the length of the scalar projection. So that's the component in the direction of BC of our vector BA. And then what we have on this side is our vector BA. And so our value D is just going to be the square root of just kind of the completion of that right triangle. It's going to be the length of our vector BA squared minus the square of the component of BC in the direction, or of BA in the direction of BC squared. Oops, let's fix that. So by this, we really mean our vector our vector BA squared. So for our vector BA, we have ending point minus beginning point. So we have 3 minus 2. Then we have minus 1 minus 1, and 2 minus 5. And so for our vector BA, we have 1, negative 2, negative 3. For our vector BC, we have, again, ending point minus beginning point. We have 1 minus 2. We have negative 2 minus 1. And we have a negative 2 minus 5. And so that's going to give us a negative 1, a negative 3, and a negative 7. So with this, now we're able to compute our components, namely our component in the direction of BC of BA is going to be BA dotted with BC divided by the length of BC. And so for this one, we have BA.BC is going to give us a -1 plus a 6 plus a 21 over the length of BC, so that will be the square root of 1 plus 9 plus 49. And so what we end up with is our vector 26, or value of 26, over the square root of 59. For our length of BA, we have the square root of 1 plus 4 plus 9. So we have the square root of 14. And so now plugging this into our value for D equal to our square root of BA squared, so that will be 14, minus then the square root of 26 over the square root of 59 squared. And so what this will give us is, so that will give us the square root of 150 over 59, which gives us 5 times the square root of 6 over 59. Or if we want to rationalize the denominator, we have 5 times the square root of 354 over 59. So I hope you've enjoyed this video, and I will see you guys in the next problem. Take care.